Hello everybody, Root Beer here, and I'm hopefully as eager as you are to continue on with the 2004 grade 7 Gauss paper. We're going to specifically be looking at question number, what are we up to? We just did 14, so now we're going to be on question number 15, okay? So question 15 here. If P equals 1,000 and Q equals 0.01, which that should be, we got two zeros, so it should be 1 over 100. So we got 1,000 and 1 over 100. Which of the following calculations gives the largest result? Okay, now one way we could do this is we could just calculate each of these. They're not that hard. P plus Q, P times Q, P divided by Q, Q divided by P, and P minus Q. And we're even allowed to use a calculator, so why not? Well, one of the reasons we might not want to do it is because it'll take time, especially if we're writing it out by hand. But calculators can also have their pitfalls, and you press the wrong button, you're not going to notice it, and you might think the answer is A when it should be E or something like that. Okay? But if we just sort of think about this not as 1,000 and 100th, but as really big number, really small number, we can sort of just look at the possible answers and sort of think our way to maybe getting a solution, or at least narrow it down. And if you practice things like this, and then think about the numbers this way, and oh geez, does a big number divided by a big number give us an even bigger number, or things like that, or which is better, adding two big numbers or doing a big number divided by a small number, that sort of thing. If you practice that sort of stuff, you can sort of think your way to answers really, really quickly on these types of questions. And I think I said it in the last video, or maybe it was 2 videos ago. Anything we can do to speed up our process on the A part and the B part questions will give us more time for the C part questions that are worth more and demand more of our attention because they're just that much harder. Okay? So, the key things for me, thinking my way through this question, are that P is very, very big. So this is a way to write very, very big, much bigger than 1. And Q is much, much smaller than 1. Okay? And this is going to become important for our answer. So a big number plus a small number is basically the same as the big number. The small number doesn't really add anything. Same thing if I took the big number minus the small number. It's basically the same. It's sort of equal. That's why we use the wavy equal lines. It's basically the same thing as P. So that's A and E carried away. Now we've got P times Q. And if we do P times Q, a number that's much bigger than 1 and a number Q that's much smaller than 1, they sort of cancel out. They sort of cancel out. And so I would guess this is probably about 1. Okay? The idea is that they cancel each other out. Roughly. They don't combine to create some super big number. Okay? And now, we're left with P over Q and Q over P. So I'll do Q over P first. So this is a small number divided by a really big number. Whatever it is, that's going to get very, very small. Much, 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 much smaller than 1. Okay? I admit I'm abusing the notation for people who know this, how this works. And with P over Q, the opposite happens. If you have a really big number divided by this very tiny, much less than 1 number, it actually gets really, really big. It goes in the opposite direction. It gets really, really huge. Much bigger than that P ever would be. Okay? General rule of thumb. If you are the tops are the same, and you divide by the one that you divide divide by the smaller number with, that'll be the bigger quotient. So for example, if you had A over B and A over C, and you knew that B was less than C, then this one would be your bigger one. And if you divide by the same thing, okay, and you know that B is less than C, the bigger one is going to be what matters. Okay? So these are just some general rules of thumb. So without doing a single calculation, and being able to, and since I know this well enough that I can just do this in my head, I know that this one's going to be my answer, and that is C. Okay? But maybe you're not ready for that, and that's okay. Okay? Everyone goes at their own speed. The point of the math contest is to have fun, primarily. Maybe if you're thinking long term, to prepare yourself for the harder math contests that you can get rewards for, like scholarships to various universities. But you should never think that you're trying to compete with, me or anyone else in your class. I mean, if you got another math buddy, it's nice to have a friendly rivalry. But don't take it too hard if you're not the smartest math kid writing the paper. The only person you really need to compete with, and I know it sounds cheesy, is yourself. Okay, if you're practicing this grade 7 Gauss, and you're doing okay, maybe you don't understand a couple of things I'm talking about, maybe you get a 70. Or, maybe you do even worse, maybe you get a 40. Your only goal when you write in whatever year you're writing is to try and beat yourself. Try and do better than you did, because that at least shows to yourself, wow, I am getting smarter, and I am getting better. And one of the things you can do, and this isn't just with math, but as you go through the education system, sometimes you can stop and reflect and say, wow, I have learned a lot. I am much better at math or history or chemistry than I was so long ago. Okay? But, again, if you're not there, that's okay, because we can still do this question with a calculator. And I'm going to go through it with the calculator, and you're going to see that P over Q really is the very big answer. It's a massive standout. Okay? So, what have we got here? We've got P is equal to 1,000. So we're actually going to use the numbers now. And Q is 0.01. So I'm going to go in the same order. I'm going to leave the P over Q for the very end. If I add these two, if I need to, I can grab the calculator, but I can do that one in my head. This one, I'm going to grab the calculator. I think it's 999.99, but I will double check. 1,000 minus 0.01, not 0.1, and we get 999.99. And you can see, I was right. They're basically just 1,000. They're only slightly off from 1,000. PQ, I think this is going to be 10, actually, but compared to 1,000, 10 is basically 1. Okay? So that times 0.01, we can grab our calculator, 1,000 multiplied by 0.01, and we do, in fact, get 10. Okay? Now let's take a look at Q over P. If we wanted to, we could write it as a fraction, 1 over 100 divided by 1,000, and so it'll be 1 over 100,000. But we can also just grab our calculator, 0.01 divided by 1,000. Okay, and we get 0.00, I want to make sure that I got the right number of zeros, 1. And this is also 1 over 100,000. Okay, same number of zeros as long as you do include the 0 before the decimal. And now the big one, P over Q. This is going to be 1,000 divided by 0.1. You can grab your calculators and go along with me. 1,000 divided by 0.01, and we get 100,000. Much bigger than 10, much bigger than 1 over 100,000, and much bigger than either of these numbers, P plus Q and P minus Q, that were basically 1,000. Okay? But the actual specifics of the numbers didn't matter. We were able to do this just noticing that P is a really big number, Q is a really small number. Okay? And so that's how I would go through that question really quickly. And if you practice thinking about the numbers in this way, questions like this, and every once in a while there is a question like this, they will just come to you like that. You'll just be able to say, okay, P's the big number, Q's the really small number. What have we got? Oh, there's the big divided by the really small. That's going to be super big. Okay? But either way you did it, C is the answer. So that's question 15, I think it was. Yeah, and in the next video, we're going to take a look at question number 16. So thanks for watching, and of course, I'll see you guys next time.